want to welcome you to the webinar, Understanding and Preventing Bird Collisions, hosted by the Audubon Society of Central Maryland and Safe Skies, Maryland. It's my pleasure to introduce our speaker, Dr. Scott Loss, an Associate Professor of Natural Resource Ecology and Management at Oklahoma State University. He has a PhD in Natural Resources Management from the University of Minnesota, a Master's of Science in Natural Resources Management from the University of Illinois at Urbana-Champaign, and a Bachelor of Science in Wildlife Ecology and Management and Biology from the University of Wisconsin-Stevens Point. Scott's lab studies multiple aspects of global change ecology and management, including direct sources of human-caused wildlife mortality, like predation by free-ranging cats and bird collisions with structures. In this webinar, Scott will talk about key research advances from his lab and how these findings are being used to recommend collision mitigation practices, as well as ongoing studies assessing approaches to reduce collisions. So with that, I'll turn it over to Scott.
All right, thank you for that excellent introduction, Mark, and I'd like to thank you and Safe Skies Maryland, as well as Audubon Society of Central Maryland for the invitation and the opportunity to present this research. As Mark mentioned, I've been working on this topic of bird window collisions primarily from a research angle for the last 7 or 8 years. And what I'll be focusing on today is presenting a summary of the various research findings that we've had over that time period. What I'm going to be presenting today represents a lot of different projects that were coordinated with the key assistance of a lot of different people, particularly graduate students who worked with me here at OSU, and you'll see me giving them credit for their leadership on aspects of this research throughout the talk. I am at the Department of Natural Resource Ecology and Management at OSU here in Stillwater, Oklahoma. To give a little bit of a regional feel for what's going on here. I know a lot of people are interested in birds and birding here, obviously, on this talk. Today, it's really one of our first brisk fall days. Summer lasts a long time here, and when we get our first fall cold fronts, it's really exciting, and we've had a really powerful front pass through in the last 24 hours. So we have thousands, if not tens of thousands, of Franklin's gulls migrating through our area right now. We also just had our first Harris's sparrows of the winter show up, and sort of segueing into my talk, unfortunately, this wasn't a sighting of a live bird. It was a bird that was found collided with a building here on the OSU campus today in Stillwater by another faculty member in this department. So bird window collisions is the point of this talk. And I also, if folks are on social media, I have a Twitter page where I post all about various things going on in my research labs, as well as some teaching and outreach activities I do. So you can follow me on Lost Lab OSU if you're interested. So I'm sure as people that are interested in birds, you've all heard about the decline of the North American avifauna. It's something we've known about for a long time. The idea that across a lot of different bird species, populations are in decline, both at a national scale in the US, continentally in North America, and even beyond. Global bird populations are in decline. This was really hit home, obviously, about 2 years ago when this publication came out in Science, documenting or quantifying the decline of the decline of the North American avifauna, showing that we've lost a net 3 billion breeding birds in North America since 1970, or approximately 1 in 4 breeding birds. And a really alarming finding, obviously. Some interesting additional findings related to patterns in which species groups are in the greatest decline. For example, species nesting in the tundra or the western forests, the boreal forests, or grassland nesting species tend to be declining the fastest. And coincidentally, many of these same species are those that are affected by the threat that I'll be talking about today of bird window collisions. Now, the purpose of that science paper was not to really identify and rank drivers of bird population declines. However, there is a whole separate field of research that I've been really active in for about 8 years now, focused on identifying threats to bird populations, both indirect threats like climate change and habitat loss, which change the environment in the ways that indirectly affect bird populations through changes in survival or changes in reproductive output, etc., as well as much more direct types of mortality sources, things that lead to direct and immediate loss of birds' lives through mortality, and things like predation by invasive species like cats, collisions with buildings, collisions with energy infrastructure, etc., or with vehicles, pesticide poisoning, etc. This topic of direct human-caused mortality sources is something I've spent an especially large amount of my time researching over the last 8 years or so. Among these direct mortality sources, and maybe some of you have seen graphs such as this that I have over on the left here, we've spent some time over the last several years, starting when I was a postdoctoral researcher at the Smithsonian Migratory Bird Center over there in DC, coming up with data-driven estimates of the number of US birds killed by different direct mortality sources. We did this for several different threats, and other researchers have contributed estimates for some of these, like communication towers and agricultural chemicals. But for the other ones, I led efforts to take existing data and try to estimate sort of the magnitude of these direct mortality sources on a national scale. Excluding cats, which I'm setting aside, if folks know anything about my research, you'll know that I've spent time working on the topic of free-ranging domestic cats. That's really a separate issue, and it can be distracting, so I'm sort of setting it aside here, not showing it on this graph. It's obviously a huge source of bird mortality. But when we're talking about other direct threats, and specifically focusing on collision sources, bird window collisions or bird collisions with building windows are the top direct source of mortality affecting birds in North America. We estimated in a paper back in 2014 in the Condor that between 365 million up to about 1 billion birds are killed annually in the United States each year. And that could actually be a slight underestimate, given some emerging evidence from studies that have recently come out. And I'll circle back to that in a few slides. This number of birds killed is really tremendous. Obviously, it's huge. We hear a lot about things like wind turbines and the collisions that they cause being a huge issue worth managing. And that's definitely the case. There's certain species of birds that are affected by wind turbines in a way that their populations may be affected. But when just sort of ranking the threats based on total numbers of birds killed, they really pale in comparison to bird collisions with building windows, as do some of these other threats that are sometimes much publicized, like collisions with automobiles, power lines, communication towers. And anyone who knows something about this issue knows it's not just the common urban adapted bird species that collide with buildings and their windows. In fact, for whatever reason, it seems like those types of species, like the starlings, house sparrows, pigeons, for example, are pretty good at avoiding collisions, especially given the numbers of them that there are out there. We observe relatively few collisions of those urban adapted species. The ones that are largely affected are native species, particularly a wide range of migratory species, and especially long distance migrants like warblers, sparrows, hummingbirds, thrushes, etc. And the species of these, the groups within this group of species that seems to be most disproportionately affected are those that migrate primarily at night. And I'll talk a little bit about the mechanism for why that may lead to increased collisions for these species on the next slide. But we know it's a range of species affected. Some of the species that we really care about from a conservation perspective, and this is just a sampling of them here, a lot of different songbirds like cedar waxwings, ovenbirds, and a variety of native sparrows, a variety of warbler species like that orange-crowned warbler shown on the lower left, the prothonotary warbler near the middle, buntings like the indigo bunting in the lower center, hummingbirds like the ruby-throated hummingbird in the top center. And then also it affects species beyond passerines and near passerines, like shorebirds in some cases. American woodcock, shown there on the lower right, is a species that occurs in large numbers as a collision victim at a lot of cities in the eastern United States. And we've even found species like this red-necked phalarope up here in the upper right in the downtown area of a major city that was experienced a collision with a building. So it's a lot of different species. It's these native migratory species, especially nocturnal migrants. In association with that 2019 science paper documenting the decline of the American avifauna, I noted that the purpose of that study wasn't to rank the threats, right? But they still put out this really big marketing campaign around identifying what some major threats are that we can take action on and likely be able to help reduce the decline of the bird populations or reverse them in some cases. So notable to this talk is that one of the seven simple actions identified for helping North American bird populations is to make windows safer, to reduce the total number of bird window collisions that we see across our continent, across the United States. So bird window collisions, drilling down a little bit more into detail here related to this topic specifically. We've known for years what the primary mechanisms causing bird window collisions are, and those are the reflection and transparency effects of windows. Windows reflect the surrounding environment, and so when birds approach them, they may see trees, grass, or other habitat, or sky. Or in some cases, depending on lighting and depending on the arrangement of windows, they create transparency effects whereby birds see through to the other side, either to the other side of the building, they see vegetation through the building, or in some cases, vegetation used inside the building as ornamental decorations. And due to both the reflection and transparency effects, birds collide with these windows. They don't have the ability to discern the cues that would otherwise tell them that windows are there. And additionally, beyond reflection and transparency effects of windows, the issue is really exacerbated by light pollution. And this is something that's been sort of thought of or speculated about for several years. More recently, we're finding some pretty compelling scientific evidence that light pollution is actually contributing to the problem, especially in major cities. And the reason for that is that, as I mentioned, a lot of the species affected by bird window collisions are these nocturnally migratory species. And it seems like bright lights at night somehow disorient them, follow up their migration cues, like using the stars and Earth's magnetic fields, somehow messes with their migration cues, causes them to be disoriented, fly in circles, sometimes be attracted near the lighting source, close to the ground and in the risk zone of buildings where they have a higher risk of colliding. And this is a picture that a lot of you probably are familiar with. This is the 9/11 memorial light in New York, which unfortunately the timing of that memorial of 9/11 concurs with the time of year that has a high volume of fall migration of these nocturnally migrating birds. And it's just a very dramatic example of how an intense light at night can attract birds and draw them off course, as shown by these specks in those images. That's all migratory birds. In fact, the issue has gone to such a degree, and it's been well documented so much by organizations like Cornell and Audubon, New York, that there's someone that watches the beam when it's on to count the number of birds, and they give the signal to shut the light off temporarily, the lights off temporarily when too many birds are entrained in the lights, so that they can continue on their way with their migration. So light pollution is a big part of it as well, and lights at night and reducing lighting at night is a big focus of reducing collisions, as I'll talk about a little bit more later. So where does my research lab come in here? My students and collaborators and I have sort of a two-pronged approach to this issue. And one aspect of that is identifying the factors that cause collisions or lead to variation in collisions. Like what causes there to be high numbers of collisions in certain places and low numbers in other places. And the factors that we've cued in on there are things like traits intrinsic to the bird species that lead to that collision variation, temporal related factors like seasonality, bird migration phenology, and weather, and spatial factors like the way the glass is arranged on buildings, the shape of buildings, the landscaping in close proximity to buildings and in their surrounding landscape. Additionally, identifying what causes variation in collision numbers between buildings and across time periods, we have a major objective of specifically evaluating approaches that appear promising to managing and reducing bird window collisions. And some things that I'll talk briefly about today that we've worked on in this vein include using weather radar to predict when bird window collisions are going to happen, using products that are marketed to the public for collision reduction, like window films and markers placed on windows, and testing how effective they are at actually reducing collisions. More recently, we're getting a little bit more into human dimensions in collaboration with some colleagues here at OSU to ask questions about what are human attitudes about bird window collisions? What are their perceptions about this issue? And maybe more importantly, from a management perspective, how interested are they in or willing to do things related to managing or reducing bird window collisions? Understanding that helps us manage the issue going down the road. So that's sort of a little bit of a roadmap of the research that I'll be presenting in a little bit more depth throughout this talk. I'll hit on both aspects of our research program here. A lot of our research has been based on field data collection based on observations of bird window collisions in field settings. And we've done this in a variety of different contexts. One of the big places where we've done a lot of work, predictably, is here at the Oklahoma State University campus in Stillwater, Oklahoma. Especially between April and October of 2015 to 2017, we monitored 17 different buildings, both here on the OSU campus, but also more widely in the city of Stillwater, daily for collisions. This was work that has been going on here even predating my time here. There's another faculty member named Dr. Tim O'Connell who's done a lot of work on this topic, and we collaborate regularly on this. He's co-author on some of the papers that have been published summarizing the results I'll talk about tonight. But also very importantly, Dr. Corey Riding, a PhD student here at OSU who graduated back in 2019 and is now an assistant professor at Salt Lake Community College. He's really the one who spearheaded a lot of the work here with our field project at Oklahoma State University. So that was one of the settings where we've done this. Additionally, we had a field project in 2017 and 2018 focused on Minneapolis, Minnesota. And this was monitoring that we did at 21 different buildings in spring and fall migration of those 2 years. That work centered on a sort of a hot button issue or a hot button building in that region, the US Bank Stadium, which folks who are familiar with this issue may be aware that there was sort of a big public discussion about bird window collisions at this structure when the plans for the stadium were first released several years ago. Long story short is that sort of that public discussion led to the stadium authority and the football team that uses that stadium to fund a research project to look at bird window collisions at the stadium and to place them in the broader context of what's going on in downtown Minneapolis. So we monitored that building as well as 20 additional buildings in downtown Minneapolis for that study. Finally, I'm going to be talking about a few results from a project that was much bigger than my lab, a project known as the Erin Project, led by Dr. Steve Hager and Brad Cosentino. They coordinated a standardized approach to doing field sampling of bird window collisions across 40 colleges and university campuses across the US, and even including a couple of sites in Canada and Mexico, as shown here on the map by all these dots. Stillwater was also included within that. OSU Stillwater was also included within that broader collaboration. And while that work is largely led by Steve and Brad, I'll be presenting a couple of results that one of my PhD students, Jared Elmore, generated based on his time here, looking at that data set that we collectively compiled across all those sites. What did we actually do at all those sites to monitor bird window collisions? Well, I've distilled it down into a ridiculously simple slide. And for those of you who have spent a lot of time doing collision monitoring, say, and I know there's a group in Baltimore, for example, that does a lot of monitoring of large buildings in the center of Baltimore. You type of folks all know that it's incredibly difficult, time-consuming, logistically challenging work, right? And so I boiled it down here quite a bit to make it look simple and concise, but it's really, really tricky, difficult work. At the crux of it is daily collision surveys or near daily collision surveys when possible at all the buildings in our study sample. We did this in all three of those study sites that I showed there, both the Minnesota and Oklahoma study areas, as well as that broader collaboration where someone was going out on all 40 of those university campuses every day during one fall migration. And in all of those cases, the daily collision surveys, they may vary slightly, but the crux of it is walking around the perimeter of every included building in the study and looking for evidence of bird collision victims. victims, either the carcasses of the birds that are left there, left over, or feather piles that may result when birds collide and predators or scavengers remove a part of the carcass, or smudges of feather marks or bird imprints on the windows where the collisions occurred. So that's the crux of what we did, these daily collision surveys. In both our Minnesota and Oklahoma studies, we also did a couple trials to try to get at some factors that cause us to underestimate collision mortality. Specifically, we know that when birds collide with structures like buildings, that scavengers and humans sometimes remove those birds before we're ever able to get to them in our studies, right? So if you don't account for that removal bias, you'll underestimate number of birds killed. So in both the Minnesota and Oklahoma study, we've conducted experiments where we place birds in known locations at known times, and we can then track how long they persist and then correct our estimates of collision based on that removal rate. Similar idea with detection. We know that no surveyor is perfect. Regardless of your amount of experience in doing these surveys, you miss some birds. So we do detection trials where an independent observer puts out birds for surveyors to find, and the surveyors are blind to that test. They don't know they're being tested that day with that bird. So we can determine the proportion of those known birds that are being found by surveyors and account for that bias as well. I'll touch a little bit on this topic of removal and detection before I get into the rest of our results, but we've looked at this really in depth in our Oklahoma study, again, work led by Corey Riding as a PhD student here at OSU. And we found in our study system here that when a bird collides, it has a 91% chance of persisting to the next day, meaning that if we do daily collision surveys, we're going to miss about 9% of the birds that collide, because that's the rate of removal, right? 91% persistence, 9% removal on a daily basis. And this equates to about 11-day mean persistence time on average for carcasses. This changes really dramatically depending on the system and depending on the scavenger community, it seems. We also found that the top removers of these bird carcasses were domestic cats and opossums, as shown using trail cameras, which we placed to track what was actually removing the birds that we placed to get at removal. We also found some interesting things for moving carcasses, like the greater roadrunners, which we have here in Stillwater, will occasionally remove a bird carcass, and turtles, of all things, we've found to try to remove and start to consume bird carcasses. So you find interesting things when you start to ask what's removing bird carcasses. Here we didn't find humans doing it because we coordinated really well with our cleaning crew and buildings facilities maintenance crew at Stillwater, at OSU Stillwater, so that they would not be removing birds if they found them. But in other places, like in major cities, human removal is arguably a much bigger issue than animal or scavenger removal. We also found that persistence time of these carcasses was affected by season and carcass size, with higher removal rates happening in fall, and larger carcasses predictably lasting longer, not being removed as frequently. Peak removal was also during the overnight period, not surprising given that the primary removers were nocturnal scavengers. We also looked at this, like I said, in Minnesota, and one really interesting thing we found is that if you look at this on a building by building basis, the removal rates are tremendously variable, especially with humans as the key removers, like was the case in Minnesota. We found that the rate of removal from night to night varied from, or I should say the rate of persistence varied from 4% to 70%, meaning that depending on the building, there was either a 4% chance up to a 70% chance of a bird that collided being there to be found the next day. And that's tremendously important if you're thinking about making comparisons between buildings and the number of birds that collide. Any differences that you observe could be entirely related to removal by people, and thus the importance of sort of accounting for that factor. For detection, in our Stillwater study, we found that 73% of the carcasses were found by observers, and that, not surprisingly, if you're more experienced, you're going to find more of these carcasses. And if the birds are landing on easy to search substrates like pavement, they're easier to find. I also hinted that bird window collisions may, our estimate of bird window collisions of up to 1 billion birds may be an underestimate. Both our study in Stillwater that shows cats are a large remover, of bird window collision victims. And this recent study published in a journal called Biological Conservation, based on research in Argentina, which also found that domestic cats as well as domestic dogs remove carcasses to quite a high extent. This might actually mean that some of the birds that we attribute to cat predation in studies of cat predation could actually be birds that resulted from bird window collisions. And you can envision maybe you need to tweak the estimates a little bit and push the bird window collision estimate up a little bit. Maybe the cat estimate goes down slightly. But this is just evidence that this is a much bigger potentially issue than even our current estimates. So one of the things we've looked at is species-related variation in collision mortality. And going back to our 2014 study, we looked at this using data that had been already collected across the country by different organizations, different citizen science-led organizations, including the Lights Out Baltimore group. They contributed data to this, as well as other organizations across the country. We were able to look across all these data and find patterns in species vulnerability to collisions. We found that certain species, especially warblers, hummingbirds, and some sparrows, are disproportionately vulnerable to colliding with windows, especially after you account for the population abundance, meaning that the species near the top of this list collide more than would be expected just based on their abundance. Because we know that more common species would probably collide more commonly just by chance, right? But once we account for abundance, we can actually identify these sort of patterns in species-specific risks like shown here. And again, those patterns emerged of these certain species groups coming out. That data set was interesting in that the data that went into it was collected under different protocols. Using that Erin data set, those 40 sites across the United States, where the data was collected in a standardized fashion, we found some different patterns emerging using the exact same method to quantify species vulnerability. A couple of the same species came out on top again, like the black-throated blue warbler and the ruby-throated hummingbird. But others emerged for the first time, and we think that might just be because of the fact that we had previously used non-standardized data may have masked the true high-risk species, like the brown thrasher and white-throated or white-breasted nuthatch that we documented in Jared's analysis. What about temporal variation in collisions? Folks that are aware of this issue from downtown areas of cities are probably familiar with the idea that most of the collisions happen during migration, spring and fall migration. And in many cities, the pattern seems to be, or the common knowledge seems to be, that especially in fall migration is when we experience the largest number of collisions. This is a graph from a review paper we published back in 2015 showing across all the data in the US at the time, what those patterns of collisions were by months, both for windows on the top and wind turbines on the bottom, which incidentally have a pretty similar seasonal pattern of collision numbers. However, our research here in Oklahoma has found sort of an interesting alternative pattern. Migration is again the peak of when these collisions occur, but unlike in many cities where this has been studied, here in Stillwater, the peak in the number of collisions is actually during May, during our peak month of spring migration. And we were curious why that would happen. So we drilled down a little bit further and looked at differences in collision patterns between migrant birds and resident birds. And this seems to be one of the factors that causes us to have high numbers of collisions in May. Specifically in spring, as shown on this graph, we see a high number of collisions of both migrant birds and resident birds that live near our buildings that we monitor. In summer, not surprisingly, it's almost all residents because we don't have a lot of migrants going through, right, during the summer. And in fall, we see sort of that expected pattern of a lot of migrants colliding more so than resident birds. But if you look at that number, it is about the same for the fall migrants as it is for the spring migrants. So we still don't see that really drastic peak in migrants in fall. A couple of possible reasons for this different pattern. One is geographic. Most of the data on this issue has been collected on the coasts, and especially on the East Coast, out there, places like Maryland and other places on the Eastern Seaboard. Here in the Great Plains, the migration patterns are slightly different. We have a lot of migration of a lot of species, but out here on the western edge of the East, there's several species that we only get in the spring, elliptical migrants that migrate further west in the spring than they do in the fall when they're heading south farther east of us. And so species like the Swainson's thrush and black-polled warbler, for example, we only get them during spring migration here. And we see them as collision fatalities during spring, but not in fall. So that might be one explanation for getting a high amount of spring collision mortality, including almost equally high number of spring migrants as of fall migrants. Another is just related to setting. Here on campus, there's a lot of vegetation, a lot of ornamental plantings. The city is relatively isolated. We're not that big, and we're surrounded by rural areas, grasslands and forests and woodlands. And as a result of that, we have a lot of resident birds in close proximity to our buildings, native species, especially like robins, Carolina chickadees, titmice, etc. During their breeding season in spring and early summer, they're moving around a lot, they're territorial. We think they're colliding in large numbers due to that sort of breeding activity in spring and early summer. Whereas in a place like the East Coast, especially in big cities, there aren't a lot of resident birds around these large buildings like skyscrapers to collide. The residents that are around are tending to be those non-native species like house sparrows and pigeons that are pretty good at avoiding collisions. So the takeaway here is that that seasonal pattern of migration being bad it holds here. But depending on where you're studying this issue, you might find slightly different patterns of the relative number of collisions in spring versus fall migration. We've also looked at temporal timing of collisions within the day. Corey did a subset of days where he monitored buildings in the morning, midday, and evening. And he found with that experimental setup that the vast majority of collisions we observed here in Stillwater occurred during sometime before our early morning surveys, which started about 7 or 8 o'clock, depending on the time of year. We didn't do middle of the night surveys to determine what time of the night they were occurring. It seems like most of them are near daybreak, but we can't really confirm that based on our data. And I would just like to note that the same pattern has emerged when other studies have taken this approach, including in our Minnesota study. We did the same approach to doing multi-surveys per day and found that most of the fatalities are found on our early morning surveys and many fewer in midday and evening. There's other factors that contribute to temporal variation in collisions, and one of the big ones it seems like is weather. In a lot of cases, it seems like inclement weather is particularly bad. For example, in Minnesota, our study up there, we sort of got lucky and documented an occurrence of a large number of American woodcock collisions. Say lucky from a scientific perspective, being able to document this, but unlucky for the birds, obviously, and their conservation. But what we found is that the pattern of when they collided was really strongly correlated with a few inclement weather events, specifically some pretty heavy early spring snowstorms that corresponded exactly with the peak timing of woodcock migration through that region. And that was what seemed to be contributing to large numbers of collisions. We did an analysis and found specifically that low clouds and heavy precipitation correlated to large numbers of these woodcock collisions. More broadly, using the Minnesota data set, a previous master's student here at OSU, Serena Lau, looked at this same question across all birds to see if there's weather-related factors that predict when the most collisions happen. She found a lot of details related to specific weather conditions at specific times of night in specific seasons that affect collisions. But the sort of takeaways that come from her work are that, again, inclement weather seems to be a negative in terms of causing collisions. Weather changes during an individual night also seem to be important, especially when you go from fair weather conditions like clear conditions with tailwinds to low cloud conditions or stormy conditions with headwinds. These conditions that we as birders know lead to large numbers of birds being grounded for us to see the next day. They seem to be the same conditions that lead to large numbers of collisions. And also Serena found that the weather-related factors that cause collisions seem to vary between, at least somewhat, between spring and fall migration. We've also looked at spatial factors. I'm going to try to speed it up a little here to make sure we have time for questions, but things that we found based on our studies here in Oklahoma and up in Minnesota, as well as through that Erin Project, are that the amount of glass area, both on the building and on individual building facades, is positively correlated with collisions. Amount of surrounding vegetation seems to positively correlate with collisions, probably because birds are being attracted to these vegetation areas near buildings and thus being brought into the risk of collisions. Building shape seems to matter. Our study here in Oklahoma found that buildings with alcoves, such as shown on the lower left there, seem to be particularly problematic, probably because the birds get sort of entrained in these canyon-like structures and can't escape and eventually collide. Lights at night, I hinted at this before, but we, in our Minnesota study, and again led by Serena, were one of the first groups of researchers to actually conclusively link the amount of lighting emitted from buildings at night with the numbers of bird collisions that are caused. And this leads to a really direct conclusion about potentially reducing lighting at night to reduce collisions. So shifting to the other aspect of our research, which is much more directly related to assessing potential collision management approaches. So there's a lot of interest. Many of you have probably seen these Cornell Lab of Ornithology birdcasts where there's forecasts made for numbers of birds migrating through particular regions of the United States on each night of the spring and fall migration. There's tremendous interest in using this type of forecasting system, which at its heart is based on weather predictions and linking weather to radar-based observations of bird migration volume, using these predictions to predict when collisions are going to occur. However, until we took on this question, no one had actually conclusively linked these types of forecasts and radar-based forecasts of bird migration with observed numbers of collisions to see if they're effective for that use. So we had a PhD student, Jared Elmore, pursue this question here at OSU a couple years ago. He looked at radar data from every night before our spring and fall migration monitoring days here in Stillwater. We collaborated with some radar ornithology experts at the Cornell Lab of Ornithology, Colorado State, specifically Andrew Farnsworth and Kyle Horton. And lining up that radar data, again, radar data from the night before our monitoring surveys with the number of birds we found the next day, we found a pretty conclusive link whereby more birds detected on radar at night correlates with a higher number of bird collisions found the next morning. And this relationship was especially strong when birds are flying lower as detected by radar, probably due to things like low cloud cover and headwinds. So large numbers of birds flying lower as detected by radar correlated with large numbers of observed collisions the next day. We published this paper earlier this year, and we were lucky that it got some media attention. And if you want to hear more about this, you can find an interview with me, with Jared Elmore, the PhD student that led it, as well as with Serena Lau, the master's student who's done work on light pollution at this site here, at this NPR recording that was originally aired on All Things Considered. So this result got out there to sort of a national audience through this story, which is exciting for all of us. Another thing we've looked at here is assessing various window films and markers that are installed on glass to try to reduce the reflectivity and transparency effects and reduce collisions. So we've tested a specific feather-friendly film. Feather-Friendly is the company that makes these 2x2 circle films, which I think I saw in the background on Angela's camera. It seemed like she had the exact same pattern that we tested here at OSU. So we've worked with Feather-Friendly and also with the OSU Transportation Department to put this film on a number of glass bus shelters here in Stillwater. We focused on bus shelters because they're smaller and easier to treat, cheaper to treat as well. And we thought it was sort of a good beta testing environment to see if we could test the effectiveness of these films. We also observed in a baseline study led by Chrissy Barton, a tech that worked with us for a year. We also found that these bus shelters cause collisions, so we know that there was a chance to observe a reduction in collisions if we treat them. The work that was led after the bus shelter's been treated was that was led by recent graduate here, Georgia Riggs, who just finished her master's degree here at OSU. So she gets credit for the actual data I'm presenting here. What we found was really compelling. We have before treatment data from 2016 and after treatment data from 2020 for 18 bus shelters that we treated in 2019. And we found about as compelling of a signature as possible, suggesting that these window films are actually effective at reducing collisions. Between 2016 and 2020, the number of collisions actually increased at the shelters that we didn't treat, suggesting some sort of background process that might have caused an increase of collisions. Whereas at the treated shelters, we saw a significant reduction in collisions. So really compelling evidence that even though there was something going on causing more collisions in 2020, the treatment with the film was able to reduce collisions relative to the baseline period, which is really promising for the effectiveness of these films and marketing them for broad use for example, on homes or office buildings or campus buildings or even larger buildings in some cases. I see a question that just popped up. That film was specifically a product marketed by the organization Feather Friendly, and they have a variety of different products that have all been tested in sort of a lab environment at the American Bird Conservancy's experimental tunnel, where they test these before releasing the products. But this Feather Friendly 2x2 film, 2x2 circle film that we tested here is one of the only ones that's actually been now field validated in a field environment when installed on a building. I'm probably going to need to wrap it up quickly here, but I want to at least briefly mention that we're also doing human dimensions and perceptions research here to try to get an understanding of what people think about this issue, if they perceive bird window collisions as an issue worth acting on, and what they think about measures to reduce collisions. So to that end, we've recently wrapped up a study here at OSU, again, led by Georgia Riggs, our recently graduated master's student, to look at homeowners and conservation practitioners, both in agencies and nonprofit organizations, and what they think about this issue. We used an approach called a strengths, weaknesses, opportunities, and threats approach, where we asked participants to rank the various pros and cons associated with this issue to get an idea of what sort of the perception is around it. I'm not going to have time to get into too many details, but the thing that sort of jumped out across all of the respondents is that they ranked sort of the positives around doing things to reduce bird window collisions, like having fewer collisions and fewer carcasses to clean up. They ranked those much higher than sort of the cons. So for example, like maybe the challenges associated with implementing these things on a large scale, which sort of indirectly suggests that there may be some pretty wide buy-in, at least from this homeowner and conservation practitioner group, to do something about this issue on a large scale. Now, unfortunately, we tried to get responses from some other groups as well, including architects, which are obviously a really important stakeholder in this issue. But we tried really hard. We even had a contact here at OSU who's our architect at OSU try to help us get the survey out broadly. We had issues getting a large number of responses from architects, unfortunately, so we weren't able to gather information about their perceptions, but it will be very important, obviously, going forward to get their opinions on this issue. And other steps going forward would be doing things like understanding more details about maybe how much people are willing to actually pay, like how much it's worth to them money-wise to address this issue with treatments either on their homes or on the businesses and properties they manage. So takeaways related to the research here are that there's a lot of factors that predict collisions, temporal, spatial, and related to the bird species themselves. The approaches to management that we've assessed, and some others that I haven't even had time to talk about, are really promising in terms of actually allowing us to reduce collisions on a large scale. But there's a lot of more research to do, looking at the varieties of different treatment types and different settings and different regions with different bird groups affected, et cetera, to really have a lot more understanding of these mitigation approaches. Like I hinted at, we have ongoing research going forward here at OSU in my lab and with my collaborators and students to try to understand human perceptions around this issue, to try to get more information about things like these films and markers on a larger scale, even maybe installations on large buildings and getting data on effectiveness in those settings. We have had some very fruitful discussions with administration here at OSU, and we think we're close to doing some larger scale treatments on some new buildings that are being constructed here at OSU. So hopefully we'll have some exciting things to report on that, about treatments being in place and actually having data on monitoring their effectiveness from here at OSU. And I think another really important thing is that hasn't been really addressed that we're researching and wanting to do more of in the future is trying to understand how collisions are actually affecting bird populations. We know it's a big thing, right? It's causing large numbers of bird collisions, but which species and where are really the ones that are getting the biggest dent in their populations from this issue? That'll help us prioritize our management maybe a little bit more going forward. I'm going to sort of breeze through these last slides. We have time for questions, but I also wanted to reiterate the idea that there's some really great silver linings here in that there's a lot of laws that are mandatory and voluntary and pending, or codes or other regulations across the country related to this issue. So there's sort of a groundswell of policy interest around doing something to reduce this problem. from urban to residential settings, not just in big cities. And have to obviously give props, as was mentioned at the beginning. Maryland is really a leader on this. The Howard County bird-friendly standards, which I'm sure many of you were really integral in getting pushed through, are really a model here for what can be done policy-wise to help encourage bird-friendly building of new buildings and bird-friendly mitigation at existing buildings. The last slide I wanted to mention is that I'm also sort of a future research direction involved with a really exciting project focused on the state of Texas. This is work in collaboration with the Cornell Lab, Texan by Nature, Audubon, including several of the local Audubon groups in Texas, and here at OSU. And this project started last spring, and we've, along with Andrew Farnsworth at the Cornell Lab, coordinated a standardized monitoring approach in all of the major cities of Texas, including Dallas, Fort Worth, Houston, Austin, San Antonio, and I believe El Paso as well. And in all those cities, there's groups of volunteers going out, collecting data at least 10 buildings on a daily basis during the peak spring and fall migration periods. And I know that's happening all over the country with great groups like the folks in Baltimore and elsewhere in Maryland. But one of the things that's sort of setting this apart is that we're really coordinating across multiple cities to do the exact same thing in each city. That's going to allow us to have some pretty unprecedented data to make comparisons across cities and across different time periods, to look at effects of lighting reduction measures that are being put in place in these cities, to have even a more refined understanding of how and when we can implement lights out to reduce collisions. So that's a really exciting thing coming down the road. Hopefully you'll be seeing a lot of cool science coming out of that project in the future. The project also has a really great advocacy side to it. Folks in the cities are doing a lot of work to try to get public interest. They're doing policy related advocacy work, working with municipalities, with individual building management organizations to try to implement lights out activities on a much broader scale. And this project is really, really unique in that it's gotten some really high profile political support behind it. One of the founding members of Texan by Nature, who's one of the big groups helping coordinate this project, is former First Lady Laura Bush, and she's been really outspoken, writing op-eds, in some cases doing interviews, sort of highlighting this issue across Texas, that bird migration is a big deal in Texas. Texas is incredibly important for bird conservation. It also has a light pollution issue in many of its cities, and it's a thing that could be managed to reduce these bird collisions and benefit North America and Texas's bird populations. So it's really sort of a unique project from that perspective, and that it's been able to get a lot of political buy-in due to her support. So I think I'll leave it at that. So we have at least 10 minutes here for questions. I'll leave up the acknowledgements screen here so you can see all the folks, all the collaborators, students, et cetera, that have been really integral to all the work that we've done over the years on this topic, as well as the funding organizations that made the work possible in the first place. So thanks for your time. Again, really appreciate the invitation to be here. I'd like to take any questions that folks would have.
I'm applauding for you, Scott. I'm sure everyone else in the virtual world is.
I'll imagine that applause. Thank you all for watching. I see some questions. Would you like me to respond here?
Yeah, sure. If you can see them, I can see them as well. But you've already answered the first one, but there's about 4 or 5 more. If you want to look at that, the next one has to do with screens. How do screens affect birds?
Yeah, so screens, that's a sort of, I wish I had an easy answer. It's one of those things that seems like a really easy fix. And in some very limited conditions, it may work, especially external screens. There's examples of a couple high profile buildings. One that I can think of is the one in San Francisco at the California Academy of Sciences building. There's a natural history museum there, I believe. They have some external screens that they've lowered over some previously very problematic windows to reduce collisions. Internal screens, like the blinds on my windows next to me here, are the ones at home. A lot of times that has sort of a counterintuitive effect in that putting a solid object behind the glass, it sort of cuts out the transparency effect, obviously, but it can actually exacerbate the reflection effect. So it's not necessarily an easy fix in many cases. And in a lot of homes and like home environments, more likely than not, it's going to increase the reflection effects. That doesn't mean there might not be some color of screen that you have that it could potentially reduce the reflectivity effects as well. So I would look from the outside to see what it looks like before doing it. But like I said, likely it's going to be increasing reflection, counterintuitive to what we maybe would think.
Thank you, Scott. So the next one also is just what do dark screens that are energy savers for homes protect birds as well? So
it's a good question. There's a lot of interest when we talk to building managers and administrators. Like, for example, here at OSU, they're like, we have some screens on windows. They're like maybe really tiny fritted dots or something like that are there for energy savings purposes. And there might, again, be special cases where those could work if they're visible enough. The ones I've seen here in Oklahoma on our campus are not very visible to birds from, or at least visible to humans from a distance. So I'm skeptical that a lot of them directly transfer over to bird window collision protection as well. And that being said, there may be some. And what I would say is that I wouldn't really vouch for anything until it had at least gone through the sort of experimental tunnel testing approach that the American Bird Conservancy does up in at Powder Mill up in Pennsylvania. They have a bird banding station where they have a setup where they release birds into a tunnel and they have a choice to go towards two windows, one marked with the treatment and one that's not marked. And over a lot of different replicates of that experiment, the birds don't die. They catch them with the net, by the way. They actually get scores on these different glass types and different film types that sort of vouch for their effectiveness at deterring collisions. And those are sort of the gold standard. We think they translate over really well to a field setting as well, but that hasn't always been validated, like I said. So yeah, I wouldn't assume that anything that sort of maybe breaks up windows is effective for birds.
Scott, next one is, have you studied how light colors affect collisions? You mentioned light exacerbating stories, so light colors.
Great question. We haven't. So we just looked at the amount of light emitted from buildings at night, and it was like a really coarse metric of, I think it was just lumens, so light intensity, nothing with regard to the color spectrum. However, there is sort of some knowledge from other settings about how birds respond to lights, that different colors, parts of the spectrum are worse for attracting birds than others. And it's sort of slightly different for LED versus non-LED lights. So I'm sort of hesitant to make statements here since I don't have it in front of me. But if I remember correctly, the sort of the yellows and the oranges, those tend to be worse than some of the cooler, like purples, blues, things like that. So there is some understanding of like how birds and insects even are attracted to those lights versus not. But we've never gone beyond overall brightness of lighting in the context of bird window collisions to try to get at how those factors affect collisions. Great question.
So the next one is not really it's just a comment about someone who's put up Acopian bird savers. I guess basically it sounds like a paracord, and she said it works great, and I can vouch for that. Same, I've got 25 windows in my house, mostly big ones, and I put that up, and it was super cheap and easy, and it works great. So yeah, certainly easy to do. Thank you for the presentation. Someone puts up dark screens at their house. What research is looking at survival of birds post-collision? Many homeowners believe that if a bird doesn't die instantly, it's fine. Yeah, I've heard that's not the case, but do you have any information on that, Scott?
Yeah, this is one of these huge mysteries in the study of bird window collisions. As far as I know, there's never been data published on this to sort of get at what percentage of birds that, you know, fly away, or well, first of all, what percentage of birds that collide, right, just die on the spot versus those that fly away, right? That's sort of part one of the question. Beyond that, of the percentage of birds that fly away, what percentage live fine versus those that die eventually versus those that might live a normal length of time with some like level of impairment, and all three of those outcomes seem possible. We really don't understand that. We don't have an understanding of that. I think there was something I've mentioned powder mill a couple times, and I don't mean to put them on the spot, but I thought I remember to mention somewhere up there that they might be starting to try to do something experimentally with tracked birds to try to get at that. But we don't have data as far as I know. They haven't released anything yet.
Yeah, this is Mark, and I would just say that I've seen by email some rehab centers with some information on that. Again, it's probably not hard to tell exactly what the whole context is, but it's in their experience, it's pretty low. In other words, they might get in a bunch of birds that have been window collisions and like 10% might survive or something like that. So it's not a good number. So someone talks about it, whether you give care, and certainly the programs like you mentioned, Lights Out Baltimore and DC as well, do, collect them in a bag and take them to a rehab center. That's the practice. And what I'm hearing now is the rehab centers are not having much luck rehabbing those birds, because you might imagine with a human being hitting your head against something hard, there's a lot of things that can go wrong that aren't visible. So yeah, I don't want to take up. So you got a few more. Only looks like 3 more. Does the distance between bird and windows matter? For example, is a hummingbird flower garden about 3 to 4 feet from a kitchen window a problem?
Yeah, so there was some initial research from Dr. Dan Clem, he's one of the sort of the pioneers in this area. Much of his career has been devoted to this, and he's been researching the topic since around 1979. He's at Muhlenberg College. He had some earlier studies showing that distance of bird feeders to windows did matter, and he suggested that there's sort of this high risk range that's moderate distances from windows, and I think it was anything less than 5 feet was better, and anything greater than 15 feet was better, but in between is sort of the risk zone, because the birds that come in, when they leave, they can build up enough speed to collide. And that the ones that land at feeders closer, if they collide, they're not going fast enough. But that was an initial result, but as far as I know, no one's followed up to ask that question beyond that study. I think from my observations of bird feeders, if you're going to put bird feeders in that close range, I would still think about whether treatments of the windows are something you can do, because I still think it's not eliminating risk entirely when you have feeders that close to the windows. I didn't really get into the detailed specs of these types of things, but a lot of the window films and markers are designed based on this spacing of either 2 by 2 inches or 2 by 4 inches. And that's a really data-driven outcome that birds don't really deter from colliding with windows when elements are spaced larger than that. So like putting a hawk decal on a window, or even 3 or 4 on a big window, statistically, it's been shown that that's not very effective, because the birds think they can fly through those gaps. And so the really narrow 2 by 4, or ideally 2 by 2 is showing to be better inch spacing of these elements is really key.
I would agree with that, Scott. And what we've seen in the last year or so is that there are some vendors out there who are suggesting it be wider because they can sell them more easily, but they're not effective. So that's something to be aware of, that there are some folks out there just trying to make money off of this, which is sort of sad. But 2 by 4 for most birds, 2 by 2 for hummingbirds is important. So I'll just go with 2 more questions. We're finished. One is, you mentioned this before, why do urban dwelling birds seem to have lower rates of window collision than other birds? You mentioned the invasive or exotic birds.
That's a great question. I know I can't interact with folks, but hi, Chi Ming. Chi Ming is a good friend from graduate school in Minnesota.
Okay, good.
It's not a planted question, I promise. And Chi Ming, we probably need to collaborate on this topic, because I just sort of mentioned the idea that those urban birds like sparrows and pigeons seem to avoid collisions for whatever reason, but sort of like the mechanisms behind that are really completely unknown. It might be something about, I don't know, individual behavior and their sort of increased familiarity with the settings that they're in, like over individual lifespans even, they might be learning about buildings and staying away from it. It could be something longer term in an evolutionary context about these species groups, and the fact that they're really adapted to these urban environments. There might be something also within their hardwiring that causes them to be aware of their urban environments better. But those are total speculations, just hypotheses that could be tested, I think.
Sounds like a research question. So we're 8:04, so let's just do one last question, what I think is appropriate. From Julie Dunlap, it says, what's the most compelling data from your research to use to communicate the importance of this issue to homeowners or to building managers?
Well, for homeowners, one thing that came out of our Condor paper back in 2014, where we estimated national mortality, I didn't mention this, but the number of bird collisions happening at houses across the country averages about 1 to 3 per year. Obviously, there's outliers, right? And that's not a big deal at an individual level, but across all the houses in the US, it's as big of a deal as like collisions at skyscrapers and other big buildings. So it's a huge issue. The contribution of homes to this is a huge issue. So that's something to motivate it. I don't know, I find that a lot of times folks and people on this call probably know a lot about birds and maybe even which birds tend to collide at their homes more than others. But a lot of times it's just pointing out that it's not those species that you think are the most abundant in colliding, like those pests. It's the ones that you know and love the most in your yard, like your hummingbirds, for example, or your cardinals maybe, which do collide in relatively large numbers at homes. So yeah, sort of putting a face on the problem seems to be really helpful in that type of context, and also the broader context of how big of an issue the collisions with homes are. For building managers, I think the mindset's a little different, and I don't claim to fully understand, what they're thinking about. They have different thoughts about what's affecting their decisions. There's policies about how buildings have to be made for safety and things like that. I've gathered some of that, and so they're thinking about all those different things. It's not just about reducing bird collisions, so that they have a lot of things to think about. But one thing that I found very useful is just any data at all that shows where specifically and when specifically it's a problem, if it is a problem with a specific building or set of buildings that they manage. I found that the data is really compelling to getting people to think about actually being able to do something about the issue. Like if you can actually just treat this one part of your building, you could address a huge percentage of the problem. And suddenly the interest in actually, thinking about how to manage that issue becomes much greater versus, a statement of we need to treat the whole building, right? And there may be situations where the whole building is a problem, but in a lot of cases, monitoring of the building will show that it's 1 or 2 hotspots, and that information is really compelling to convincing them towards management.
That's great, Scott. And I've had the same experience. Sometimes they'll just say, well, I don't think it's a problem, and then you show them the data. And a good example that I'll close with is that Maryland Department of Natural Resources building TAWS in Annapolis. And we have a map showing the percentage, and they've been doing this for 17 years, counting how many birds have died, because there are a bunch of wildlife people in that building. And so they can point out that, these 50% of the windows are the ones that do 90-some% of the collisions. So those are the ones that are being treated. And we've already put copian bird savers in many places, but are also putting out other treatments in other places that are more appropriate for the building. So that's really great. I think we'll stop now. It's been an awesome talk for me. I've learned new things. I really appreciate your time, Scott. And well, hope to talk to you again soon.
Thank you all again for having me. And I'm going to put up my email address here. Should have done that earlier. If you have questions or anything that you weren't able to ask, feel free to shoot me an email. Thanks again.
We appreciate that. Thanks, everyone. Thanks for joining.